This is a short video about AI in robotics focusing on LeRobot from Hugging Face. In this presentation, I will briefly explain the general context and then show how you can build, train, and use your own AI-controlled robot. Finally, I will touch on simulation in robotics and next steps in this field. After perception AI, generative AI, agentic AI, physical AI is now becoming increasingly important. This is especially true for the form factor of humanoid robots because we adapted the world to ourselves and because of expected labor shortages in Europe. Meanwhile, the number of AI models in robotics increased sharply on the leading AI model and dataset repository Hugging Face Hub during the last months of 2024. This is particularly due to the launch of LeRobot, a project for open-source state-of-the-art machine learning for real-world robotics. LeRobot includes models and datasets on the Hugging Face Hub, state-of-the-art open-source algorithms focusing on imitation and reinforcement learning on GitHub, and a community with more than 3,000 people on Discord. To start with this project and to build a robot, I used the AnkerMake M5C 3D printer and a Lenovo Legion T7 with an NVIDIA GeForce RTX 4080. Remote training in the cloud is, however, also possible. The initial geometry of the parts was provided in the GitHub repository, but they can also be created or adapted in a CAD tool like PTC Onshape in the browser. To 3D print the parts, they are sliced, here in AnkerMake Studio, to create the path of the printer nozzle. The parts are then finally printed in PLA Plus with an 0.4mm nozzle. These are then the parts of two robot arms, a leader arm and a follower arm, which is trained by using the leader arm. In addition to the printed parts, servos, driver boards and other components are required. The final setup includes both arms, two webcams, which will be the eyes of the follower arm, and for a simple pick-and-place task a Lego brick and its container. To train the model, the data must be collected. This is done by recording 50 episodes of a simple pick-and-place task. The Lego brick is therefore placed at various initial positions and then moved into its container by teleoperation. In addition to the joint positions, the video data of the webcams was recorded so that the robot can work independently later on. After the data collection, the dataset was uploaded on the Hugging Face Hub to share it for possible future training of other models. Then the model was trained by using the action chunking with transformers algorithm, which was published in 2023. In simple words, this model uses the webcam feed and the joint positions at inference time to predict the next joint positions to accomplish its task. LeRobot includes additional algorithms, like the diffusion policy, which is based on the same idea than diffusion models in AI image generation. Moreover, the LeRobot team is working on integrating human-in-the-loop reinforcement learning, which significantly outperformed imitation learning baselines and prior RL approaches. Especially interesting are current research directions focusing on the transition to large behavior models, effectively integrating language, vision, and actions in one model, and moving from single task to multitask execution. After about 2.5 hours of local training, the robot was able to complete the task successfully on its own, based on the webcam data. This means without human intervention, and this for randomly positioned Lego bricks. Sometimes the robot initially failed to pick up the Lego brick, but it then corrected its actions accordingly. Notice also that LeRobot is very general. Here I chose a specific robot arm and a specific task, but I could have chosen a completely different one, which might obviously increase the difficulty of the task. Finally, I want to briefly touch on simulation. The problem of real robot prototypes, especially humanoids, is that they are expensive and take time to learn. These problems can however be solved by sim to real. This means training a robot in a simulation and using the trained model in reality. As an illustration, this video shows a digital twin of the follower arm in Mujoko, guided by the real leader arm. Similarly, robots can be trained in NVIDIA Omniverse's Isaac Sim, which combines the physics engine with ray tracing for observation generation. Notice here, for instance, the box falling due to simulated gravity. The next steps are obviously to scale up the ideas in this presentation by collecting massive amounts of data, developing general-purpose foundational models, mass-producing humanoids, and gradually introducing them in factories and homes, while not disregarding political, economic, social, ecological, and legal considerations. Numerous companies are already working on it, and if you want to know more about it in an open source context, consider trying out LeRobot. If you enjoyed this video, make sure to like, subscribe, or leave a comment. See you in the next one.